So now I'm going to talk to you about bringing stereographs to XR headsets. This is a passion project of mine. Like, you can imagine that bringing stereograph is not, like, once again, coming from industry, this is not a money-making endeavor. This is more of a really bringing back to my roots of watching Viewmasters, etc. Like, just to put you back in context, last year we presented how we were able to take stereographs that were directly on stereo cards, and how we could repurpose them and watch them on a 3D screen. That was a very big endeavor that we had. So we developed that solution. It does work, but you know, that's good for a handful of 3D enthusiasts in 3D screens. So the question we were asking, you know, XR headsets, they're like everywhere. Can we develop something that will work for that? And honestly, the existing XR solutions didn't work. Didn't work for many different reasons. Like, some people do it, but they will painstakingly look at every single stereographs, and they will carve out the left eye, carve out the right eye, try to do some correction, use different software to do it, take it again, try to put it side by side, and try to watch it on a VR headset. And it's going to work-ish sometimes. Sometimes it's going to be pretty bad, and you're going to zoom in, you're going to be going crazy. So, like, it doesn't work. Like, nobody's going to use that. So we decided, okay, can we tackle this problem? So we had a few objectives. First, using existing scans with SVG files. So that's how it was designed, the original solution. So we don't want to work, like, we don't want to do any editing. We want to take, somebody scans or takes a picture of a stereo card, and that's the start. And then we create the SVG files with our own format, and then we're able to view this. Second, guarantee comfort of viewing. That's always the tough ones. We don't want anyone to have any pain or describe any fatigue or eye strain. Support 3D zooms. That's one of our killer features with our technology, is that you can zoom in, zoom out, and you can go deep inside, or you can go push it back a bit. Maximize depth perception. So obviously when you go on a smaller screen it's different, but on an XR headset we have way more depth budget. So how do we exploit that? Ease of navigation and interaction, and last but not least, support MR viewing mode. So when not just put somebody in a VR environment or a blacked out environment, because if you don't do that you will lose orientation. No, we want people to be seeing the environment, and boom, they have that stereograph in front of them, and it's a perfect experience. So there were unique challenges. Like, I won't go deep tech, because it's not the point of this. It's more about the application. But the challenges that we had when we started the project was, well, first, where's the screen? There's no frame of reference, right? So with a 3D display, it's very easy. The screen is there. Now, there's no screen. Where do we place the geometry? Where do we place the image? How do you define plane zero? What is that even, right? What's a zoom in a 3D environment? How, like on a 3D screen, again, it's very easy. In a 3D environment, when there's volume, it's a bit different. Where you position the image in 3D space, especially in MR mode, that was quite challenging, because we didn't want to have like any interference with objects that are around, so we didn't want any depth conflict. How do you add menus and seamlessly integrate them in experience? That was a big one, because what we want to do is make sure that when people see the pictures and you pop up menus, or you have different things, or even laser pointers or whatever, that there was not going to be any depth issues and clashes that will make it uncomfortable. And how to render to each eye, because usually when you go in Unity, or Unreal or any game engine, you just compose a scene, you put your objects there. Now we have two objects in the same space, and one's supposed to be seen in one eye and the other one in the other eye. How do you do that? How do you work with the shaders, etc.? It's a little bit more tricky. So the basic model is very simple. So the first thing is to define our planes. Like, what are the different planes that we have? So first, there's the virtual camera plane, where the user is. This is where we're going to put our cameras, right? Pretty straightforward. Then there's the maximum depth plane and the minimum depth plane, which are basically the ones that are going to be comfortable to watch. There are plenty of different papers out there that explain, depending on the screen distance or whatever, what is the maximum and minimum depth plane. We're using one model and we're calculating, and it's very important to understand, you know, where the virtual screen plane is, which is the gray square there. So once you understand where the virtual screen plane is, even if you don't see it, you have it, and then you know what's your budget and how you can work within that. And then step 3 is defining the size of the image and the framing. So where do we put the left eye and the right eye, and what's the right size for that thing? And understanding, like in this example, for example, we say, okay, we make sure that plane 0 is where the image is, because then we perfectly control if we put other stuff around, we know that this is, you know, this is the right plane, and then if we put stuff around, then nothing's going to be conflicting with what's on the screen. And then when we zoom, what we do is we say, okay, there's a minimum depth plane, a maximum depth plane, there's a new image plane. So before, the image plane was the depth plane, minimum depth plane, but now we're moving it around. So we need to redefine what's the size of the image, what's the right distance, and like all of this is done with our technology and our calculations to make sure that we keep the exact same X, Y, and Z experience. So basically is when we push it back, we have a very calculated, it's not just like pushing it back and that's it. No, no, no. We resize the image, we recalculate everything to make sure that the image plane and the image follows the image plane, and that at that time it's right there. So we can once again have full control of where everything is, and we can put stuff around, and it works really well. So yeah, I'm good on time. All right, so this is what the application looks like. I'm going to be at the demo session as well, so no worries. You can come and ask me and come and see a demo. So basically what you have is on the left, you have the different categories of different types of images. So you have with your remote on MetaQuest 3, you can select with the laser pointer, and yes, it stops at the right place when you say stereograph, and then you go and you select whatever stereo image you want to see. Now once that is done, and this might seem trivial, but this here, maybe I go here. Yeah, there you go. See, like one of the important thing here is that when you put the laser pointer, it stops exactly at the plane of the image. So instead of like seeing, like usually because the depth information is not correctly done, you will see double pointers, and you will have a hard time fusing the little CS3D at the bottom there. It's going to be conflicting. So when you watch something, then everything becomes blurry, or it starts doubling up, etc., and it becomes a very bad experience. Now, some people have higher tolerance to these bad experiences, but in general, people find it extremely annoying, and after 2, 3, 5 minutes, they just give up and they move on. So that's why they say they need to take a lot of pauses. So here you can see that it stays at the right plane, and it's the same thing here. And by the way, this is my CTO's home office, so I think you can see a guitar in the background as well. So anyways, so we were able to do that. Once again, like the way that the images that you saw, what we do, we created a black frame. This is a new thing that we've just started. We found out that putting that black frame around creates a frame of reference, which makes it a lot more comfortable for people. They have that magic window. And with that magic window, and you know, we've added another thing. When you see the demo, if you move a little bit to the left and to the right, you see a little bit more to the left, a little bit more to the right. We've made sure that the motion parallax is faithful to the normal experience. So when you move, the background doesn't move, the foreground moves a little bit, And therefore, it creates a very natural experience, not nauseating at all. So this is actually pretty cool. So next step, obviously with stereographs, a lot of degradation. None of them were really mint condition. So we're going to work on automatic picture restoration. Obviously, you know, you have little imperfections in the pictures, and some are really degraded, so it detracts from the quality of the experience. So we really want to move on that. Right now we have one fixed anchor place. We want to be able to take it, move it to the left, move it to the right, and it's, well, the other way around. It's really easy to do, but we haven't done it yet, so that's the next step that we're going to do. We want to improve the natural 3D experience for certain stereographs. So right now we're analyzing the pictures and we're making sure that we respect plane 0, deep plane, etc. But sometimes some of the stereographs are not that great, and people were taking pictures, you know, from like a big landscape, from, you know, the Great Canyon. Boom, Grand Canyon. They would take a picture, but at the end of the day, everything is very, very far. So if you use that technique, it will, like, you will zoom like crazy, but it will not feel natural. So we are working on algorithms to analyze what the different pictures are and recreate a very faithful experience. 3D thumbnails, we didn't do it yet, but we want to, when you select, we want to have 3D thumbnails because, well, because that's cool. And that's it. If you have any suggestions, very open to them. So there you go. Thank you very much.
Thank you. Okay.